Hi guys, welcome to the post-contest discussion of the Codeforces Round 974. I am Abhinav and this is TLE Eliminators. So let's get started with the first problem in today's contest. So the first problem is Robin helps. So here we are given that Robin encounters n people starting from the first and ending with the nth. The ith person has AI gold. uh, so we are just given n people and the number of gold that every people has is given in the form of an array. If AI is greater than equal to k, Robin will take all AI gold. If AI is equal to k, Robin will give one gold if he has any. Robin starts with zero gold. Okay, so what the problem says us is we are given an array which just represents the count of the number of gold that each of the person has. And then we are told that if AI is greater than equal to k, we are given a threshold k. And if one by one, Robin would start with the first person and he would one by one go to the nth person. And if AI is greater than k, the number of gold that ith person has is greater than k, Robin will take all of his gold. And if that person doesn't have any gold and Robin has at least one gold, he would just give one gold to that person. Okay. And if AI is between 0 and k, nothing will happen. So we have to just follow this sequence and then find out how many people Robin gives gold to. We just need to find for how many cases where it would be this case where Robin gives a gold to any person. Okay, so like if we see the second test case, okay, here we are given this is n and this is k. So we are given this array 3, comma 0, comma 2. Okay, so and we are given k equal to 2. So what would happen? Robin would start with the current number of gold that Robin has is 0. Initially, Robin doesn't have any gold. He would start with the first person. He would check if this AI, which is 3, if this 3 is greater than equal to k, which is 2. So since 3 is greater than equal to 2, it is satisfied. Then all these 3 gold will go to Robin. Okay, so he would take all its gold and Robin would now have 3. After this, he would go to the next person. Now, since he has 0 gold, he doesn't have any gold. Now, Robin can give 1 gold to this person if he has any. So, yes, since Robin has some gold with him, he would give 1 gold to him. Okay. So, -1 to this and +1 to this. And we would also count this thing, how many times this happens when Robin gives a gold to any person. So, in our answer would be the count of that. So, initially answer is 0. If this happens, we'll increment the counter of our answer. After this, again, the next person has 0 gold. We would check if Robin has some gold available with him. Yes, then he would give 1 gold to him. Okay, and we would increment our answer by 1. Okay, once everything is finished, this is our final answer. So we just need to implement this thing. Okay, just what dry run I did here, we just need to implement that in our code. One by one, move to every uh, index and just check if we would just one by one move to every index from 0 to n minus 1 and we would check if the AI is greater than equal to k. What we would do in this case, we would make AI 0 or just make it or not, it would not matter after this. So we can just skip this step and the number of gold that Robin has, let's store it in some variable, let's say current. The number of gold Robin has, current is initially 0. We'll increment that by AI. And if this is the case, and if AI is equal to 0 and Robin has some gold, so the current is greater than 0, then what we would do, we would decrease AI or do it on, it doesn't matter, but we would, sorry, increase AI and we would decrement current, the number of gold that Robin has, that would be decremented by 1 and our answer would be incremented by 1. Yes. So the number of cases where this happens that we have to count in our answer array, answer variable. So that would be incremented by 1. So that is what our code is basically. We just need to write this. Okay. So you can just see the code also. Okay. It's the same thing. We took the input n and k and all the variables. the array input. After this, what we did, in current we initialize with 0, answer we initialize with 0, then just one by one. This is a loop from I equal to 0 to less than n. Okay, so this is basically a loop. I've defined it. So, uh, just understand that. So AI is equal to 0 and current is greater than 0, then answer plus plus current minus. These two things, what I told. If AI is 0, and in this case, we did current minus minus and answer plus plus. AI plus plus is not required because that AI won't be used after this. So it doesn't matter if you update it or not. And if AI is greater than equal to K, then the current would be increased by K. So just do what is given in the question and your final answer is this. Okay. What would be its time complexity? So this is the input. Taking the input takes O of n time for taking this array. And this n times, this is just if else condition. So this is taking constant time. So this we are doing n times. So overall O of n and O of n, our overall time complexity is O of n. Okay. And you can see the constraints of the problem. N is just 50, K is 100. So no problem at all. Sir, can we do this without using vector? Also write just by variable. Yeah, like without using vector, you are telling for AI that I'm taking. Like while taking the input only, you can just write this thing inside here. So you would not require a vector. Yeah, that's obvious. While taking the input here, you can write this. So it would be the same thing. Okay. I hope it is clear. The first problem is clear to everyone. If there is any doubt, you can ask me. Otherwise, we'll move to the second problem now. Okay. Okay, so let's move to the second problem. So let's read the problem. Measure O grows I to the power I new leaves in the ith year. It starts with one leaf in year one. Okay. Leaves last for K years on the tree. In other words, leaves grown in year I last between year I and year I plus K minus 1 inclusive. Robin considers even numbers lucky. Help Robin determine whether the measure O will have an even number of leaves in year n. Okay, so let's understand what the problem is saying. So it's saying that Robin grows I to the power I leaves in every ith year, and each of the leaves lasts for K years. Okay, so what does that mean? Let's say what would happen on year one. Okay, year one, Robin would grow one leaf. Okay, year two, Robin would grow 2 to the power 2 tree. And so the total number of leaves, okay, let's see. Then year three, he would grow 3 to the power 3 leaf. Year four, he would grow 4 to the power 4 leaf. Okay, so let's say we need to find in year three how many leaves are there. So it would be 3 to the power 3 plus this leaf plus this leaf. All of them would exist till where? Till a K is given us. So let's say if K is 2, then each leaf lasts for 2 years. So let's suppose if K is 2, it means in year 3, leaves from year 3 and year 2 and year 1 will last. So for year 1, 1 plus 2 is 3. So this all the 3 would last. For year 4, what all leaves would be lasting? Leaves from year 3 and year 2 would last, but leaves from year 1 would not last because 1 plus 2 equal to 3. So this leaf would last only till year 3. It would not last in the fourth year. Okay, so if we need to find the number of leaves, let's say the number of leaves in ith year. Okay, what would that be? That would be the that would be I to the power I is the number of leaves in the ith year. Then how many leaves are remaining? Leaves from here would also be here. Okay, so I minus 1 to the power I minus 1 is also here. Then I minus 2 to the power I minus 2 is also here. And till where? Till up to I minus K plus 1, you can say. Okay, so 4 minus 2. Okay, I minus K. Check between year 1 and okay, it's inclusive, so I plus Okay, sorry. For year 4, if k is 2, then from year 2, it would not last. Okay.
Excuse me, sir.
Yeah. Yeah. Yes. Okay, I
Sir,
said that wrong. For year 4, leaves from year 2 would not last. Leaves from year 2 would last only for year 2 and 3, if k is 2. Okay.
sir, so
So,
basically,
yeah.
can we say that we would take last k terms starting from n raised to the power n? Like for
Yeah.
here, if it is 2, yeah. But sir,
Yeah. Yeah.
I
Yeah.
also did this, but it was again and again showing maybe wrong answer on test 2. Then with the help of my friend, I was able to submit it, sir.
Okay, let's see. Let me explain after that. Tell. Okay, so what does that mean? So if k is 2, it means this year 2, this leaf would last for 2 years, this year and this year. It won't last in the 4th year. So we can say for the nth year, the leaves that would last would be the leaves from this year and the leaves just before that up to the last k terms, basically. So if k is 2, we would take the last 2 terms. If k was 3, we would take the last 3 terms. So basically for the ith year, we would take how many terms? K terms here. From I minus 1, I minus 2 up till. So k terms would be uh, I minus k plus 1. Okay, so these would be the k terms. Now, so this is the number of leaves that would be present in the ith year. So let's say this is our function. So f of I is the number of leaves present in the ith year. This would be the expression for that. Now, what we need to find here is consider even number. Help Robin determine whether the major oak will have an even number of leaves in the nth year. So we just need to find whether this particular thing is even or odd. Just that's what we need to find. Okay, so like if you see some test cases, let's see the second test case, which is n is 2 and k is 1. So we just need to find whether fn is even or not. Okay, so if you see for n equal to 2 and k equal to 1, our fn would be, so in the first year, there would be 1 to the power 1. Second year, there would be 2 to the power 2. And k is 1, so we would only take 1 year. This would not be there. Okay, so fn would be just 2 to the power 2, and which is 4, which is even. So we would say yes, it is even. Okay, the second test case is yes. Okay, so in the code, what we need to do, we need to just find whether this particular thing, this fi that I wrote, okay, or I've written I, you can replace I with n. Okay, so we just need to find whether this fn is even or not. So how can we find this? Okay, even means this modulo 2 should be 0. So basically we need to find, so we'll write that fn is n to the power n plus n minus 1 to the power n minus 1 plus up to n minus k plus 1 to the power n minus k plus 1. This modulo 2. Okay, so like by the property of modulo, if you need, if we have something in plus, you can just break this bracket and write everything, this modulo 2 plus this modulo 2 plus this modulo 2 and so on. So you can just basically write it like n to the power n modulo 2 plus n minus 1 to the power n minus 1 modulo 2 and so on. Okay, what is n to the power n modulo 2? Like if you just uh, think what it would be, if you can just divide this into two cases. If n is even, then any even number raised to any power, it would always be even. So this would always be 0. So n modulo 2 would be equal to 0 if n is even. So like you can just think, it's very basic that if n is even, any even number raised to any power, it would always be even number only. So for even number, modulo 2 would be 0. And if n is odd, okay, let's say n is 3. 3 raised to 3, what would it be? It would be 27. What would be 5 raised to 5? Okay, whatever that would be, that would always be odd. Like you can just write anything, any x raised to the power, like n raised to any power modulo 2 is same as n modulo 2 raised to the power x. So you would, for an odd number, n modulo 2 is 1. It would be 1 to the power x. It would always be 1. That is like a mathematical proof I have given you for that. For an odd number, n modulo 2 would be 1. So 1 raised to any power would be 1. So for odd case, n modulo 2 would always be 1. So basically, for the odd terms, you would have 1. For the even terms, you would have 0. Simply. And you know these are consecutive numbers. So if n is odd, so this would be 1. Then n minus 1 would be definitely even. After that, it would be 1. So basically, I can say my Fn, which was n raised to the power n mod 2 plus n minus 1 raised to the power n minus 1 mod 2 and so on. So this can again be divided into two cases. If n is odd, we can just write this one would be 1, this would be 0, plus 1, plus 0, plus 1. This sequence would continue. And if it is even, this one would be 0. So 0 plus 1 plus 0 plus 1. This one would continue. So I hope this is clear. And then you just need to find whether this sum, you would have k terms here. Whether this sum modulo 2 is like odd or even, whether this thing is odd or even. That's what you need to find. Here also there would be k terms. So if you can get that, now what you just need to do, if this k is even, again you just need to find out in this range from n to n minus k plus 1, from n going down up to k terms, how many odd numbers are there. That's what you need to find. So what would this sum be? This sum would be number of odd numbers between n up till n minus k plus, okay, the last k times. Okay, so if k is even, so it would be just k by 2, basically. Half of k, half numbers would be odd, half numbers would be even. Uh, if k is even, and if k is odd, then if k is odd, let's say k is 5, then you can have 1 0 1 0 1 or 0 1 0 0. So it would be either seal of k by 2 or floor of k by 2. Now, whether it would be seal or floor, that would depend whether n, this first number, is odd or even. Okay, so you can write if k is even, you can directly write your answer as k by 2, whether this is odd or even. Okay, and if k is odd, okay, your sum would be k by 2. That's what I'm telling. And then you have to check whether this sum is odd or even. Okay, and if k is odd, you would again have two cases. If n is even, so it means it's starting with 0. So it would be k by 2 floor division. And if n is odd, it would be k by 2 seal. Okay, basically this modulo 2 to check. I hope this, how we got to this expression, you are clear on that part. If you have any doubt on this part, you can ask now. And you can like have many ways to write this expression using XOR and other things also. Okay, so whatever way you want to think, you can think. It's just about even odd only. This problem was just about just thinking about even odd cases. Okay. So in our code, we just need to write this. If k is even, just do k by 2 and check whether this is, if this thing is even, this is then answer a yes, else answer a no. Basically that. And for k odd, either it will be 1 0 1 0 1 like this. So when n is odd, it's starting with odd. So seal of k by 2. In like C++, so how would you write seal of k by 2? It would be just k plus 1 by 2. Like normal division between two integers would give you floor division. So this can be written as simply k by 2. But to do the To get the seal, you can do k plus 1 by 2. This will give you the seal of k for division with 2. Okay, so that's what you need to write in your code. I hope this thing is clear. If there is any doubt, you can ask. We'll move to the codes. Basic if else. Okay, like you can look at the code. What I have written, that x is number of that k by 2 or whatever, right? So x is the total sum. So this is k by 2 in this case, and like in this case also it is k by 2 only, right? Even if k is odd, the floor division of k by 2 we can write it as k by 2 only. If k is integer, we would get the floor division. So in both these cases we can write it k by 2, and only for this case we would need to write k plus 1 by 2. So I'm writing it k by 2, and if k is odd and n is odd, both k and n are odd, we would add a plus 1 to our answer. Okay, so basically k by 2 would give me one less number, so I'll add a plus 1 to it. In my code I've done that. You can write the if else that I wrote in the pseudocode that I wrote. You can write this also, no problem. While during the contest I did it like this. So x was k by 2, and if n is odd as well as k is odd, we will do x plus plus. Now x stores the sum, basically my function. Now we just need to check whether this x is even or not. So this yes no just means if x mod 2 is 0, then see out yes, otherwise see out. Okay, it's this only. So if x mod 2 is 0, we would see out a yes, it is even, otherwise. So I hope this is clear to you. You can directly get the sum of class data. Yeah, I think we can sum them up also. K is not too big in the constant. No, k is up till 10 to the power 9. So if we are just doing the sum one by one, that would give you a TLE. Get the sum of class data. Okay, you got us AC. Then if you're doing one by one, then according to the constraints, it should give a TLE. Maybe in the final testing, it may fail. But okay, technically, it should give a TLE if you're doing one by one. Okay, so I hope this problem is clear to everyone. If there is any doubt. Okay, so I think we can move to the next problem now. Okay, so problem C, Robin Hood in town. There are n people living in the town. Just now, the wealth of the ith person was AI gold. But guess what? The richest person has found an extra pot of gold. Okay, basically, there are n people and everybody has some gold in it. After that, what happens? Whoever has the maximum, the richest person, AJ, we would add X to that person. So the richest person would get some X extra gold. Okay. After this, when that is added, after this, it is said a person is unhappy if their wealth is strictly less than half of the average wealth. So after adding X to the maximum person, whatever the average is, if for a person his wealth is less than half of the average, then that person would be unhappy. Now, if strictly more than half of the total population N are unhappy, so if more than half of the people are unhappy, Robin Hood will appear by popular demand. So we need to determine the minimum value of X for Robin Hood to appear, or output -1 if it is impossible. Okay, so these are the conditions given for Robin Hood to appear. Now we are told this X can be a variable. You need to find the minimum value of such an X so that Robin Hood appears. And if that is not possible in any case, you need to output. Okay, so like let's look at an example to understand more clearly like what we need to do. Okay, let's say this is the test case. You are given that this is n, and you are just given an array 1, 3, 20. So what you need to do is you have to find such an X. Let's suppose that value is X. Now this x would be added to the maximum value. Here in this array, what's the maximum value? This 20 is the maximum value. So this 20 would be replaced by, let's suppose we take x as 5. Okay, let's suppose we are taking x as 5. This 20 would be replaced by 25. So our new array would be 1, 3, 25. Now for this new array, we would find the average. So for this, the average would be 29 by 3. Okay. So we'll take the real number only. It would be 9.67. Okay. So this would be the average. Okay, this would be the average. Now, for each person, we would determine whether that person is happy or unhappy. So a person is unhappy if his wealth is, if AI is less than half of average, then the person would be unhappy. Okay, and it is strictly less than. Okay, strictly less than half. So we would check this one, first person. So this one and half of average wealth. So half of average here is half of 9.67, which is, I think, 4.83 something like that. Okay. So this one is less than 4.83. Okay. So this person would be unhappy. 3 is also less than 4.83. So this person would also be unhappy. And this 25 is greater. So this person would be happy. Now, how many unhappy people are there? There are 2 unhappy people. Okay. So now we would say that number of unhappy people is 2. Now we need to check whether this 2 is strictly greater than half of the number of people. Okay. So number of people was 3 here. So half of 3 is 1.5. So this 2 is greater than half of 3. So yes, we would say Robin Hood would appear in this case. So in this case, we would say that Robin Hood will appear. Okay, so this was the case when we took x equal to 5. So for x equal to 5, Robin Hood will appear. Now we need to determine the minimum x so that Robin Hood appears. Okay, so maybe if we took a lower x, then after final calculation, we may get that this is not greater than, only, let's say only one person is unhappy and rest are happy, then Robin Hood will not appear. So for some lower x. So we need to find the lowest x for which Robin Hood appears. Okay, I hope the problem statement is clear to you. So like for this case, the answer was, for the first test case, the answer was, this was the second test case, I think. Third test case. It was the third test case. Answer was 0. So 0 was the minimum value you need to put. So even if you take x equal to 0, Robin Hood would appear in this case. Like you can analyze any other test case also. So I hope the problem statement is clear so that you can look what we need to do. Okay, it's clear what we need to do. Now, how can we do this? So like instead of taking x, let's suppose x is a variable for now. So for this array, let's say we had this array only 1, 3, 20. Let's suppose we increment the maximum by a value x. So it would become 20 plus x, 3 and 1. This would be my new array. So now my average would be 1 plus 3 plus 20 plus x divided by 3. Basically, this thing is the sum of the array, sum of my initial array. So I would say the sum of my initial array plus x divided by this 3 was n. Okay. So in a general case, we can say for any array, my average would be sum plus x by n. Okay, so for a general case, I can say my average would be sum plus x by n. This would be my average. And what would be half of my average? So let's say I'm writing half average, just divided by 2. Okay, so this would be my half average. And we need to find whether this half average, we need to find the number of people who are unhappy. Basically, the number of AI for which AI is less than this half average. Okay, let's say I name it AVG half. So we need to find the number of people who are for which AI is less than AVG half. So this thing we can, so how many people would be less than this value. And like we need to find this count, how many people are less than this. Let's say there are C people who are less than this AVG half, less than this thing. Then we need to, for Robinhood to appear, we want to make Robinhood to appear. We need to find the minimum X for which Robinhood appears. So this C should be greater than n by 2. That's the condition that it should satisfy. So there should be at least, we can say at least n by 2 plus 1 people, you can say, or more than n by 2. So here again, you can see if n is odd, let's say 5, then n by 2 would be something 2.5. So we need to have at least 3 people. Okay. And for even case, n by 2 would be exact. So plus 1. So basically it's n by 2 plus 1 for even, and n by 2 plus 0.5. So n plus 1 by 2 for odd. Okay, that you can manage odd and even case. Okay, so this would be my requirement. There should be at least that many people. Let's say this is required, is the number of people. So it's n plus 1 by 2 in one term, you can write. For even also that would work. So this is the number of people required. This is the like number of people that must be unhappy. So if we want this many people to be unhappy, how can we have that? So like you can just see, if you sort this array, then you can basically analyze it more in a clearer way. This array was already sorted, so you don't need to anything. So whatever you are given, just sort this array, and then for the last value, that would be the maximum value for it, a plus x would be added. And now since this is the maximum value, this would, a maximum plus something would always be greater than the average by 2, that is for sure. So we know for this person would always be happy. Now there would be some people below. So the lowest person, he may be unhappy. Then if we sort the array, basically if we have some people and that arrow is sorted, there would be some unhappy people at the start. After that, all the people would be happy. It would always be like this. It won't happen that there is some happy people and above it there is some unhappy people. If this particular ith guy is happy and the array is sorted, then I plus 1th guy is having some greater value. Then if this, he is happy, then he would also be happy. So it would always be something like this up till some value, it is unhappy. And what is the count of this value? This count should be greater than our required. So basically, if I get my required, the condition for me is that A of the required. So the first person is, if I'm taking a zero-based indexing, what is the, like, if I need this many people to be unhappy, then with what is the index of this required person? So that would be basically for I equal to required A of required minus 1. Okay, so the first person is A0, second person is A1, third person is A2. So A of required minus 1 is the basically the person till which we should have unhappy. And after this, from A of required till A of n minus 1, they should be happy. They can be happy, there can be unhappy here also. But A of 0 to this. Okay, sorry, let me write it. So if this is the array, I'm saying till this, they are unhappy, till this, they are happy. So what is the index of this particular person? Okay, if we need required number of people, so that would be required minus 1, and this would be required. So I'm telling A of 0 to A of required, they should be definitely unhappy, required minus. Okay, I'm taking zero-based indexing, that's why it's A of required minus 1. With one base, it would be A of it. So these many people should be unhappy. So my condition for unhappiness is whatever is this things, all of them should be, for them to be unhappy, all of them should be less than my half of average. So it means if this is less than half of average, all the below ones would also be less. So basically my condition is A of required minus 1, this would be less than AVG, half of the average. So if I can satisfy this condition, then satisfying this condition, the minimum x that I get is my answer. So this half average was sum plus x by 2n. So I would say a of required minus 1 should be less than sum plus n plus sum plus x by 2n. Okay, so this 2n we are given, sum we are given. So basically x would be greater than a of required minus 1 into 2n minus sum. Okay, this is the condition we get. So the minimum value of x that is needed is this. Okay, so a of required minus 1 into 2n minus sum. So what are these terms? So basically, this is your final answer. This thing is the minimum x that you need. So where your sum is the sum of your initial array, which you can get, and n is the size of the array, which is already given, and this required is what you need to find. So a of required minus this can be in odd even case, you can write it n plus 1. Okay, so just find this. So I think it's quite clear what you need to do. Just find the sum of the array, then then just check required is this, then just check this value, sort the array. After that, just find the value of this. It would be your answer. Okay, I hope it's quite clear. Yeah, for odd and even case, as I said, this was my required. For odd case, it was n plus 1 by 2. Like if you have 5, what is the required? How many people should be unhappy? 3 people should be unhappy for it to be greater than n by 2, which is greater than 2.5. So that's why if we do 5 plus 1 by 2, we would get 3. So for odd, it's n plus 1 by 2. And for even, you can write it is n by 2 plus 1. And you can also write n plus 1 by 2. It would give you the same value in case of even. So for integer division, n plus 1 by 2 would work for both the cases. But if you have doubt, you can write for odd n plus 1 by 2, even n by 2 plus 1. Okay. So I hope that is clear. Last final answer part. This is my last final answer. If you have any doubt, you can. Okay, so now we can move to the code. It's very simple. Okay, what I did, this was the input part. After, okay, one more case that we need to cover here is like for small inputs. I think it would be covered anyways. Yeah, for the minus 1 case, when would our answer be minus 1? So like you can see, we need to have how many values this required, which is n plus 1 by 2. So like for small input, let's say n is 1, there's only one value. Okay, there is only one value. Let's say something is there. Now, whatever you do, this would only be the maximum value. This would be incremented. So the average would be this only. So we can never have less than half of average as its value, because average cannot be less than half of average. This value would only be average. For n equal to 1, obviously you can never make it make more than half of the people unhappy. Okay, and for n equal to 2 case also, for n equal to 2 case, what is the required? You need to make half of 2 is 1, so you need to make 1 plus 1 2 people happy. Basically, you need to make both the people happy. So again, you cannot make unhappy. Again, you cannot make both the people unhappy for this case. If you have a0 and a1, so as you know, the last person can never become unhappy. He would be the highest person. He would get some more extra x, and his average would be equal to, or his value would be either greater than or equal to the average. It cannot be less than half the average. So basically, you can always say for n equal to 1 and n equal to 2 case, you can never make people more than half of the people unhappy. So if n is less than equal to 2, I can say you would print a -1, you cannot. For n greater than 3, for n equal to 3, you need to make 2 people happy. Okay, your required would be 2. Half of 3 is 1.5, so you need to make 2 people happy. That you can always do. Just increment the, if you have 3 values, this increment this value to a very great extent, then it would increment the average and make it greater than both of them. So you can always make it for n greater than 3. There is no problem. So -1 case would only be here. So just check that case before only, and after that do what you need to do. Okay. So what I'm doing now, if n is less than equal to 2, I would print a -1 and return from my. We don't need to do anything further. Okay, and if n is greater than 3, then we will do all the things. So sum is I'm doing using the accumulate function. You can just take a variable and add it, run a loop and add also whatever you wish to do. So this way I'm taking the sum, I'm sorting the array. Okay, this all of a just means a dot begin comma a dot end. Don't get confused about it. So it means a dot begin comma a dot end. So I'm taking the sum, I'm sorting the array. Then my required value is, okay, here this required variable is something else. Here this required variable is basically this thing. Okay. In my code, I'm telling this thing as my required, which is a of, this is n plus 1 by 2 minus 1 into 2. Okay, so n plus 1 by 2 minus 1 is same as n by 2. Okay, like this n plus 1 by 2 minus 1, if you write, this can be written as n plus 1 minus 2 by 2, which is n minus 1 by 2. Or in both odd and even case, for n by 2, it would work. You can check for odd and even case. Okay. It's the same thing. So a of n by 2 into 2. So this is what plus 1. Okay, you can write this what we derived here. Okay, or you can check both of them are the same. Okay, so this thing is same as what I wrote. So you can write what I wrote there also. So this I'm taking as required, and then I've checked if this required minus sum. One more thing I'm checking, that this may be a negative value. So you cannot have a negative x. So if this is a negative, when this one is greater than less than sum, we would get some negative value. So if sum is greater than this thing and we are getting a negative value, we would print 0 as our answer, not a negative value. That x cannot be negative. We can only have positive of x. So if x goes negative, then just print 0. We don't need to add anything. Otherwise, print this requirements. Here my required is this thing. I hope it is clear to you. Okay. Yeah. You can use binary search on answer also. There's no problem, but it would add an extra login complexity, but that would also work. There is no problem in that also. Here we were able to derive the formula directly, so we use it. But yeah, you can use binary search on answer also in this case. No problem with that. Okay, I hope this problem is clear to you all. If there is any other doubt, you can ask. Okay, I think we can move to the next problem now. Okay, Robert Hood and Miss Hood. So Robert's brother and mother are visiting, and Robin gets to choose the start day for each visitor. All days are numbered from 1 to n. Visitors stay for d continuous days. All those d days must be between day 1 and n inclusive. Okay, so we have n days, and there are some visitors. So basically, Robin's brother and mother are the two visitors, and they would stay for d continuous days among those 1 to n. So we would have a segment of d continuous days in between those day number 1 to day number n. And for these days, they would stay. Robin has total of k risky jobs planned. The ith job takes place between day Li and Ri inclusive. So basically, we are given k ranges from Li to Ri, and those ranges represents the range of the duration of every job. There are k jobs, and every job has a duration from Li to Ri. If a job takes place on any of the d days, the visit overlaps with this job. So that job may overlap with the visiting day of any one person. So then we would say that one of the job overlaps. It doesn't matter the length of the overlap. Robin wants his brother's visit to overlap with the maximum number of distinct jobs and his mother's minimum. So what Robin wants is that his brother's visit that should overlap overlap with maximum number of distinct jobs, and his mother's visits should overlap with minimum number of distinct jobs. Find suitable start days for visits of Robin's brother and mother. There are multiple suitable days. Choose the earliest one. Okay. So basically, we need to find the suitable days for Robin's brother and mother's visit. So, okay. So let's understand the problem. I think by taking a test case. Let's say we state this test case. Okay, let's take this test case. So what we are given is this is n, d, and k. So there are n days, n is 7. So there would be days from day 1, 2, 3 up to day 7. Okay, there would be 7 days. And d is 2. So the length of the visit for his brother or mother is 2. And k is 3. So there are 3 basically jobs that he would do from a range of 1 to 2. So first job would start at 1, end at 2. Second job would start at 1, end at 3. Third would start at 6, end at 7. Okay, so let me draw them. Okay, so this is day number 1, this is 2, this is 3, 4, 5, 6, and 7. So what we are given is he has 3 jobs. Okay, so the range of these jobs would be from 1 to 2. Okay, so one job is from 1 to 2. Another job is from 1 to 3. Another job is from 6 to 7. So these are the 3 jobs. After that, we are given D is 2. Okay, so we need to find 2 ranges. First is the range of days for the visit of brother, which should overlap with maximum number of jobs. And for the mother, it should overlap with minimum. What does that mean? So we need to basically find a segment of length 2. Let's say we take this first 2 days. Okay, and then 2 basically it means day 1 and day 2. Let's say we take this segment which has 2 days. Okay, so if we are taking this segment, it is overlapping with how many jobs? This job and this job. Both of them it is overlapping with. So if we are starting with 1, it would overlap with 2 jobs. Okay, let's say we are starting with 2. We take these 2 days. Again, it would overlap with this job for this day and this job also. So again, it would overlap with 2 other jobs. If we start with 3, it would overlap with only this job. So 1. If we start with 4, okay, so if we take these 2 days, it's not overlapping with any of the jobs. So 0. If we start with 5, these 2 days, it's overlapping with one job. And if we start with 6, these 2 days, it's overlapping with one job. So basically we saw if we start with 1, it was overlapping with 2 jobs, two jobs, 3, 1 job. And then for 4, it was 0 jobs. For 5, it was 1 job. For 6, it was 1. Okay. So this way we can, for every starting point, the number of jobs it's overlapping with. So my answer would be for his brother's visit, we need to pick the job for which there is maximum overlap. So maximum is 2 here. So we can pick either this or this as the starting point. So if there are many equal maximums, we need to pick the earliest one. So for the brother, the answer would be this one. So for the brother, we would pick this range basically for the brother 1 and 2. Now for the mother, we need to pick the job with minimum overlap, which is this 0 overlaps 4. So we would pick this. So for the mother, we would pick this one. Okay, so starting point is 0. So my final answer is going to be 1, 4. I think you can look. This was the third test case and my answer was 1. Okay, I hope the problem is clear what we need to do. Now, how can we do this? Okay, so if you look at the constraints of the problem, it's given n is 10 to the power 5. D and k are also up to n, so they are are up to 10 to the power 5, L and I all are 10 to the power 5. So for this, like the brute force approach, what we did here, in that what you would do, you would check for every case. So if you start with one, you would check in this range how many jobs are overlapping. So for this, for every checking, you would need to check all of these jobs. So there are total k jobs. So for every day, you would check for all the k jobs how many are overlapping. That way you can find these values for every day. For first day, two are overlapping, two. But what would be its complexity? There can be n days, so n times, and in every time to check, you are checking with k of the all the k jobs how many are overlapping. So it would be O of n into k, the brute force approach. And since n and k both are going up till 10 to the power 5, so it would go 1 in 10, which would give you a TLE. So you need to basically optimize it a little. Okay, so how can you optimize it? So what you can do is, like, for every job, to find out what we need to optimize. If we are checking for every job, we are taking k steps. We are like every time checking for every job which are in this range and which are not in this range. So like we are moving to all the ranges one by one. So this k checking, this can be optimized a little. Like if we are checking here, then if some job is greater than this, then why to if any job is starting after this, then why to check this? And if any job has already ended before that, then why to check this? So what we can basically do is, first thing is, you would need to sort these k ranges. Okay, so these are some ranges that are given to you. Now sort them either based on starting point or ending point. Okay, let's say we are sorting them based on the starting point. Okay, so first, now this array is already sorted based on starting point. If it is not, first thing that we did is sorted them based on the starting point. So this is coming first, after this, after this. Okay, now what we can do, while moving one by one, when we are at the ith position, we need to check how many jobs are overlapping from I to I plus uh, D minus 1. Okay, so we need to check how many jobs are overlapping in the range from I to I plus D minus 1. How many jobs overlaps with this range? So what we would do, we would like use a kind of a two-pointer thing of approach. So one I would be represent the day on which we are checking. Okay, I represents the day on which we are checking. Okay, and then a j, we can keep a pointer to traverse through this array. So what we would do, if we are at I, so we would one by one put these ranges which have if any of the range are before this. So for the first, starting with 1, we can go up to 2. So all those ranges which are starting before 2, they can be put into some, let's say, in some data structure, we are putting them up. Now all those which are starting after this, we just don't need to consider those, right? Okay, so we'll put all those things which are starting before the ending point of our first range into something, some container, let's say. Now, among them, when we are moving, we would have to remove from it all those ranges which have already ended before. Okay, let's say we have moved our current range here. So this range has already ended before. So we would have to remove it. Okay, so how can we do this optimally? Like let's say you are putting all the range in the form of, let's say, in a vector only, in some array you are putting. Then in order to remove all the ranges, you would have to one by one check. So what you need to remove when you have moved ahead, you need to remove uh, in what order you need to check. You need to check in the order of the ending points. So basically what you can do, you can use a priority queue and store the ending points in that priority queue. So a priority queue would always store either in ascending or descending order. You can keep it like that. So what we need here is we have to just remove all those which has ended first. That would be removed first. It would be one by one removed on the basis of order of ending points. Okay, so whichever whoever's if this priority queue is storing the values in ascending order, then whichever is at the top of the priority queue is the oldest. So that would be removed first. So one by one from the priority queue, whenever we are moving to a new range, all those who have a starting point in this range, add them to the priority queue. Okay. And all those who have an ending point before this range, remove them from the priority queue. So at max, the priority queue would have k ranges inserted and k ranges removed. So at max, there would be 2k number of insertions and removals. So in total, there would be k log k would be the time complexity. Every insertion takes a complexity of log k. So n is the traversal. So in O of n plus k log k time, we can calculate this using a priority queue. Okay. So like if you got the intuition, let's do a dry run to understand what I'm telling, what I'm trying to do here. Okay. How I'm using a priority queue. If you didn't get, let's say this last test case. Okay, what I'm doing first, I would sort these ranges on the basis of starting point. So after sorting, it would be 1, 3, then 2, 3, then 4, 8, then 7, 9. So this would be my sorted order. After that, I have to move in this order. And then one by one, if, okay, so what I would do, I would keep maintain a priority queue. Okay, so initially let's say my priority queue is empty. Okay, so I would check for every range. I would start, let's say my range is starting from 1. Let's say my range is starting from 1. Okay, and I have n equal to 9. So I have my range till 9. So for I equal to 1, the length of my range is 2. So initially when I equal to 1, I would have my range from 1 to 1, 2. This would be the range. Now when I'm entering this first range, all those ranges starting before 2 would be pushed to my priority queue. So this is starting before 2, this is starting before 2. They would be pushed to my priority queue. So I'll push 1, 3 and 2, 3 to my priority queue. Okay. And I would remove all those ranges which are before 1. So there are no range which is ending before. Now they would be arranged on the based on the priority of the ending points. So instead of putting both, actually we only need the ending points. So I'm just putting the ending point in my priority queue. So I'm just putting 3 and 2. Okay. Because after once they are pushed, their starting point does not matter, only their ending point. So I'm just putting the ending points into my priority queue. So it's 3 and 3. Now, since my starting point is 1 here, all those ranges which are before this, they would be removed. So there is nothing before this. So at I equal to 1, for the range between 1 and 2, there are two elements which are in my priority queue, this and this. So basically for this, there are two ranges which are overlapping. Okay. So now I would move to I equal to 2. So I equal to 2 denotes this range from 2 to 3. Okay. So it denotes this range from 2 to 3. Now for this range, first what I would do, all those ranges ending before 2, all those ranges ending before 2 would be removed from the priority queue. Now here you can see it is 3 and 3. There is nothing before 2. So nothing is removed from my priority queue. And I would add all those ranges which are starting with this 3. Okay, now 3 is also in my range. So, but my next range is 4. So this won't be put in my priority queue. So my priority queue would remain the same and its size would be 2. So the size of the priority queue represents the number of ranges that are basically overlapping. Now I would move to I equal to 3. Now my range is from 3 to 4. Please explain again, I guess. From what part you have missed, if you can tell, then I can explain again, or I hope if you can tell from where they were. Okay, what I'm doing basically is I have these, I'm putting in my priority queue whenever I'm going to an index. All those, if I'm at index I, then I plus k minus 1, this ending value of the range. All those uh, all those ranges which are starting before this 3 would be pushed to my priority queue. So all those ranges starting before this 3 would be pushed. So these ranges are starting before this, they would be pushed. And all those ranges which are ending before this, they are removed. So when we are moving, so basically when we are sliding, like you can see here. So when we are here, so all those ranges in this range, they are pushed. When we have moved here, okay, there is nothing removed. Now, when we moved here, this is out of range, it would be removed. So removal is based on ending point and push is based on starting point. Okay, so I have sorted that ranges on based of starting point. So I would, if I'm pushing, so I'm making sure if I'm pushing some range, some ith range, all those ranges starting before are also pushed. And if it is ending before, it's removed. So my priority queue is maintaining all the ranges which are in my range from I to I plus k minus 1. Okay, I hope it is clear. For I equal to 1, my range is 1 to 2. So in this range, there are two values which are in my priority queue, this and this. Okay, the ending points are in my priority queue. When I move to I equal to 2, it's 2 to 3. So there are two ranges, again this and this, which are overlapping. So my priority queue is having 3. When I move to I equal to 3, I would check all those ending before 3 would be removed. So again, these both are ending at 3, not before 3. So they are not removed. They are still overlapping. Add my ending point is now increased to 4. So all those starting with 4, it would be pushed. Okay. So my J pointer was initially at this. After the first push, it went here. Now it was here. Now this would be pushed in my priority queue, the ending point of this. So my priority queue had 3, 3. It would have now, it initially had, my priority queue had 3, 3. Now it would have 3, 3, 8. Okay, this would be my priority queue now. And this J is again incremental. Okay, so this would be the checking. Now I would check for this range. Okay, like for here, this iteration in this turn, the size of my priority queue is 3 now. So I would say that for this range, the size is 3. Now for I equal to 4, first I would remove all those which are occurring before this I equal to 4. So these two are ending before 4. So they would be now removed from priority queue. Okay. And then the next J is this range. I would check if this range can enter it. So I equal to 4 represents a range from 4 to 5. No, so this 7 cannot enter it. It would enter when I would become, when the range is still 7. Here 5 is less than 7. It would not enter. So the size of my priority queue here is just 1. So for this case, there is one overlap. Now for I equal to 5, my range is from 5 to 6. Okay, so for the range from 5 to 6, again, you can just check if this was less than 5, it would be removed. It's not. Now for 6, can it enter 6? No, it cannot enter 6. So it's not added. It would remain the same. So again, it would be 1 only. Same for I equal to 6. It's from 6 to 7. Now it's from 6 to 7. This 8 is not going to be removed, but this 7 is going to be inserted because now my range is up till 7. So we would have one insertion here. So 7 would be inserted. It would be 7, 8. And then again, I would just, the size would be 2. For I equal to 7, it would be 7, 8. So likewise, you can just keep checking. Okay, I hope it is clear. Okay, when we reach 7, once this J has reached the end, there would be no more further insertions. There can only be removals. So here the size is 2. When I reaches 8, it's 8, 9. Here this 7 would be removed after this. This 7 is removed because it is less than the initial range. Its size would be 1. I equal to 9. The size will, it's 9, 10. 8 is also removed. It would become 0. Okay, but we'll move up till, I think we won't move to 9, 10 because 10 does not exist in n. So this case won't be. For I equal to 8, my ending point is 9. So n was 9 given in here. So I can only go up till here. Okay, so for these now, what would my final answer be? my fine for the brother, it would be the maximum. So here my maximum was 3. So for the brother, it would be I equal to 3. And here for the mother, it would be minimum. Minimum was 1, which is occurring 3 times. So the first place where it occurs, that would be for the mother. So basically for min and max, we can just maintain a variable of mx and mn and just update them whenever something is greater than mx, then just update that mx. Whenever something is less than mn, just update that mn. And along with that, also store the index for brother and index for mother. Okay. So that way, I think you can proceed. So maybe I tried using difference array concept, but I think you need to find the distinct numbers. Maybe there can be a way, I would have to think, but the problem was that you need to count the distinct numbers in a range. So using a difference array technique, you can find for a particular value how many exist by doing plus or minus. But for a range, that was how would you add those up? How many distinct are there? That was a little troubling thing to think. Okay, so that's why I came up with this priority queue approach, because that was easier to implement, basically one by one removal and addition. Okay, so let's look at the code. It would be more clear. I think the dry run, if that is the dry run is clear, let's see how we are going to implement it. Okay, so we took the input. These ranges, I'm taking the input in the form of vector of pair. Okay, this is a vector of pair. In that form, I'm taking the input ei dot, this is first and this is second. Okay, so I'm taking the input, I'm sorting it. So whenever I have a vector of pair, it would be sorted based on first. So it's sorted based on the starting index. After that, I've taken a variable to maintain the maximum size of my priority queue and minimum size of my priority queue, basically the maximum and minimum overlaps. And B stores the index of the maximum and M stores the index of the min. That would be my final answer, the indexes. Okay, so both I'm maintaining, initialized with -1 and max is initialized with 0, minimum initialized with infinity is very big value. Okay, in 64 max activity. Now I'll take a J pointer that would traverse through the basically my this vector of pair. This J is going to traverse through my ranges, vector of ranges, and I've initialized the priority queue with set to greater. So it would store values in ascending order. So my top value would be the smallest value. Now I am running a loop from I equal to 1 to n minus k plus 2. Okay, so day number 1 to the last starting day I can go is n minus k plus 1. Okay, it is less than n minus k plus 2. So it is equal to n minus k plus 1. Okay, so this is I is less than n minus k plus 2, which means equal to n minus k plus 1. So if I'm starting with n minus k plus 1, my final range would be up till n. Okay, so now for these ranges, first what I would do is push all those values. Now I would check if j is less than d, whether if j becomes equal to d, we have crossed this array. This aj would not exist. So this check is important. Otherwise, you would get an index out of bound error. Just check this, and after this, if aj dot first is less than or equal to, so this is the, if I'm starting with I would end at I plus k minus 1. So if the start of my range is less than equal to the end of my current range, then it is overlapping. Then I would push into my priority queue and I would do j plus plus. Okay. So likewise, I would push all the values which are starting before this time. So they would be pushed. Now I would pop all the values which are ending before I. So if priority queue has some size, it has some element, and its top value is less than I, then I would pop. Okay. So this way I would pop all the elements which are ending before I. Okay. So when I is incremented, if something is ending before I, they would be popped. Now I would get the size of my priority queue would represent the basically the number of ranges that are overlapping. C. Now if C is greater than MX, MX would be updated and the index of the brother would be updated. If C is less than the minimum, minimum is updated, index of the mother is updated. My final answer is B, Okay, I hope the code is also clear. Let's look what would be its time complexity. This input thing is taking O of D time. This sorting, this array is of size D, so it would take D log D time. After this, I'm initializing my priority queue. And now in this is this loop is running n minus k times. And n minus k times what I'm doing, there are two while loops, but it is a two pointer kind of thing. I'm pushing aj and this j plus plus. So at max, this push operation is running d times. Okay, d times in total, which means at max, this push operation is running for time complexity of d log d. Okay, and this pop operation at max in the priority queue, if there are d insertion, there can be d uh, erase also, only, not more than d. So at max, this pop operation is running d times. So it would have a complexity of d log d. Okay. After this, these are O of 1 operations, which are running at max n times. So overall, this loop is running at max n plus d log d time. Okay. So my final time complexity is going to be O of n plus. Okay, here also it's d log d, O of d. So it would be n plus d log d would be my final time. I hope it is clear. And this n and d were up to 10 to the power 5. So this is accepted. How we, where we use the duration d, like which duration? So this k was the, this d was the duration and k was the number of jobs. So we are using the duration here, like, okay, it should be d and k. I've used the variables opposite. Okay, d and k are exchanged in my usage. That's why it was dk. I have taken kd. So basically, the k in my code is d, and the d in my code is k. Okay, that is exchanged. No problem in that. So basically, where we are using the duration is here. Okay, k is my duration in my code. Okay, so d and k are exchanged in my code. So the duration is from I to I plus d. So basically, I plus k minus 1 just represents the end of my range. I'm checking for a range from I to I plus k minus 1 in my code, which is actually d minus 1. Okay. Okay. Yeah, in my code, the k and d are exchanged. I took it opposite. No problem. Okay, I think we can move to the next problem if there is no problem. Okay, the problem E. Uh, Okay, here we are given that travel network is represented as n vertices numbered from 1 to n and m edges. The ith edge connects vertices ui and vi and takes wi seconds to travel. Basically, we are given a graph here containing n vertices and m edges, and the edges are from basically they connect ui and vi. It means they are bidirectional edges, and this wi seconds is the weight of those edges. So we are given a weighted undirected graph here. It, it just means that only these lines. Marine starts at vertex 1 market and Robin starts at vertex n. In addition, each of the n vertices each has a single horse available. Both Marine and Robin are capable riders and could mount horses in no time, that is 0 seconds. Travel times are halved when riding. Once mounted, a horse lasts the remainder of the travel. Meeting must take place on a vertex, not an edge. Either could choose to wait on any vertex. So what does these lines mean is that there are n vertices in the graph, and some of the vertices among those n vertices have h among those n vertices. They have a single horse available. Now what they can do is Marine is starting at vertex 1, Robin starting at vertex n. They would move towards each other. So basically they need to meet at some node, some vertex they need to meet. So for meeting, they now for the travel for each road, either it would take the weight of that road, whatever, that much time if they are walking, and if they are riding a horse, it would take half the time. So they can ride a horse once they are at some node which contains a horse. Once they take the horse, they would have the horse for remainder of the journey till the end. Okay. So once they get a horse, their travel time would be reduced to half, basically. So this is given, and then you just need to find output the earliest time Robin and Marine can meet if vertex 1 and n are disconnected, output -1 as the meeting is cancelled. Okay, so if you just need to find the earliest time at which they both can meet, at any vertex they can meet. So you can decide at what vertex they should meet to have the minimum time. So both of them should reach that vertex in that time. So, and if they are disconnected, they cannot meet, you can output -1. So let's just look at one of the test case to understand. Okay, here we are given this n, m, and the third one was h. And okay, n, m, h. Okay, what does that mean? There are three vertices. Let's say this is node 1, 2, and 3. There are three vertices. M is three edges. These are the three edges, and H is one. So the vertex number 2, this has a horse in it. So we'll mark it. Okay, let's say this has a horse in it. Now, about the edges, there's edge from 1 to 2 with a weight of 4. There's edge from 1 to 3 with a weight of 10, and 2 to 3 with a weight of 6. Okay, this is the graph we are given. And then we just need to find, okay, one person is starting at node 1, one person is starting at node 3. When can they meet the earliest? Okay, so what way they can travel? So if they both have to meet, either he can reach here in 10 seconds or he can reach here in 10 seconds. So that's one way. Or he can take 6 seconds to reach here and he would take 4 seconds to reach here. So in 6 seconds, they would reach here. Or there was option in 6 seconds he reach here, take the horse, after that reach here in plus 2 seconds. So if he is going through this route, it would take 6 plus half of the time because he has taken the horse, 8 seconds only. Okay, I hope this thing is clear. So that's what. Or another way was one can travel here. So this route was, okay, if one travels here in this route, he would take 4 seconds here, then he would take the horse and just reach there in 3 seconds. So 4 plus 3, in 7 seconds he can reach. Okay, but the best thing was if he travels, he walks 4 seconds here and walks 6 seconds here. So in 6 seconds, both of them would reach at this point too. So the answer for this test case was 6 here. Okay, so for the third test case, it was 6. I hope the problem statement is clear what you need to do. So you just need to find the minimum time at which they both can meet at any point, and they are allowed to walk, and if they get a horse, then use the horse for the remainder of the journey. Okay, let's say there were more nodes here. Okay, so once he gets the horse, he can use the horse for all those. All the timings ahead would be half. So this is the problem. Now what you can do here. Okay, let's suppose this horse thing was not there. Okay, let's suppose this horse thing was not there in the problem. It was just given a simple graph and there are two people, they both need to meet at some point. Then how would you solve the problem? So this is, I think if you have studied some graph, this is a very standard problem that if if you are given two sources and they need to meet each other, so you can use, since it's it's a weighted graph, you can use the Dijkstra algorithm. Okay, you can use the Dijkstra algorithm, and once you would run the Dijkstra from the first source, once you would run the Dijkstra from the second source. So once you would run the Dijkstra from one, once you would run the Dijkstra from two. So when you run the Dijkstra from source one, for every node you would get the shortest distance from one to every node. And when you run the Dijkstra from not two, it would be three from n. Once you run the Dijkstra from three, you would get the shortest distance from three to every node. So once you have done this two pre-computations, what you can do, you can check for, let's suppose if this is the meeting point, in how much time they would meet. If this is the meeting point, the from the first Dijkstra, you would get an array, okay, which would store the minimum distance from one to every point. Okay, so you would get a vector, let's say this is d1 vector. So your d1 of I represents the minimum distance from 1 to I. Okay, and from running Dijkstra in 3, you get an array d2. So your d2 of I represents minimum distance from 3 to I. Okay, from n to I, you can say it would be n in a general case. So these two, once you have got these two things, now if you are saying that we are meeting at a node j, you would say the time to meet would be the first person would take d1 of j time to meet, and the second would take to reach here. Second would take d2 of j time to reach here. The maximum among them, that would be the time of meet. Okay, if one person is taking 3 seconds, one is taking 5 seconds, they would meet at the fifth second, the maximum amount there. So you would go to all j from 0 to n, all j from 0 to n, and minimize this value. Okay, and take the minimum among all the d1j comma max of d1j comma d2j for all the j. Okay, so in O of like n log n time, you can in using Dijkstra, you can compute this d1 array and d2 array in n log n time, and in O of n time, you can compute this max. Okay, after doing these two pre-computations. So I hope this is clear. If this h thing is not given, then it's a standard problem. How you can do? Just do the pre-computation for it. Now, when you are given this, what change would happen? Now, if you are applying a normal Dijkstra, it would now in some cases you need to consider this 4, and if you are moving from here, you need to consider this 2. That's the problem. If you have the horse, it would be 2. If you don't have the horse, it would be 4. So how can you do that in your calculation? So you have to just apply a Dijkstra on a little modified. So instead of n nodes, what you would say, you have, let's suppose you have 2n nodes. Basically, you are breaking every node into two parts, whether you reach that node without a horse or with a horse. Okay, if you break it into two parts. So initially, if I had my graph as this, okay, this was 4, this was 6, and this was 10, and a horse here. So break this graph into from 6 nodes, break it into a graph having from 3 nodes, break it into a graph having 6 nodes. So this one is broken into 2 nodes. Let's say this is, let's say I'm calling this as A1. Okay. Let's say I'm calling this node as A1, this node as B1. Okay, this 2 is broken into A2 and B2. 3 is broken into A3 and B3. Now I would say that all the A nodes, they represents that on reaching it, after reaching it, there is no horse available. Okay, so A represents that till here you have reached by walking, and moving forward also you don't have a horse available. So no horse available. So when you are on some A node, then you would have to use W as the weight. And when you are on some B nodes represent that there is a horse available. So when you are on some B node, then to travel, you would use W by 2 as the distance. So basically now my modified graph is, initially you had an edge from 1 to 2. So A1 to A2, since you are, if you're starting from A1, there is no horse available. So you would use, it would have a weight of 4. But B1, 1 to 2. So if you are starting from B1 and then you are going to B2, it would have a weight of 2 only, half of 4. So that way you can modify your graph, or just instead of forming a new graph, in the Dijkstra only, you can have an extra parameter along with the node number that you are storing. Let's say storing a node as X, store a pair of X comma 0 or X comma 1. Okay, so X comma 0 represents that you don't have a horse till now. X comma 1 represents you have a horse till now. Once you have modified it like this, then if you apply the Dijkstra on this, then you would get your correct answer. So in that, you have to just take the if condition. If there is a horse available on some node, then transfer from a node of A to a node of B. So let's say there was horse available on 2. So whenever I come to A2, I have a horse, I would transfer to B2. Okay, this transfer. So these two are basically connected with a weight 0, you can say. So whenever I am on an A node and there is a horse available, I would transfer to a B. And after that, from this, I would travel wherever I want. Okay. And if there are no horse available, these two won't be connected with each other. Basically, you cannot travel from A1 to B3, because if till here there was no horse, again, you don't have a horse here to go. Okay. But if you are here and you don't have a horse, you have a horse available, take the horse and go to B2. No. So if you have modified your graph like this and then apply a Dijkstra, you would get basically the modified minimum distance from the source to any node. Okay, so apply the, instead of the normal Dijkstra, apply the modified Dijkstra, get D1, apply modified Dijkstra, get D2, and then apply the same thing. Okay, I hope this part is clear to you. If there is any doubt, you can ask. Otherwise, we'll move to the code now. Okay, in the code, we'll see how we are managing this modified Dijkstra. If you have doubts, you'll understand better from the code. Okay, what I'm doing. Okay, this is my Dijkstra function. We'll look at it little after. So initially, I'm taking the input n and m and h. I'm declaring all the variables as global only, so that I can use in my Dijkstra function also all those variables. That's why. Otherwise, I'll have to pass in my function parameters, whichever variable I need to use. So I'm declaring them globally. Now I took n, m, and h. I just assigned this adjacency list. So I'm forming the adjacency list. N plus 1, this is vector of pair. So I'm for a weighted graph, you may know we form a vector of pair to store it. So my adjacency of u would have a list of all the edges comma weights. Okay, so this way I'm taking my input u v w. So adjacency u, in that I'll push back v comma w. So in dot first I would have the vertex, and in dot second I would have the weight of that edge from u to v. So this, since this is a bidirected edge, I am doing both of them from u to v and v to v. Okay, so this is the input part for my graph, and here to store whether a node contains a horse or not, I am using this check vector. Initially, I'm taking it at 0, nobody contains a horse, and then h inputs, all those that contain a horse, I'm doing check x equal to 1. So through this, I have assigned this check variable as whether it contains a horse or not. So check I represents, it would be 1 if it contains a horse, otherwise it would be 0. So this I would use in my Dijkstra function. Okay, so this input part is done. Now in D1, it is a vector of int. So this Dijkstra function is returning me a vector which is storing the distances from the source node to every other node. So this I got a D1 by running as one as the source and D2 by running n as the source. After that, once I have got the distances with one as the source and n as the source, okay, let's suppose I have got this. I will look at the Dijkstra after this, how I'm doing it. Then what I need to do, initialize my answer variable to infinity and then minimize max of d1i comma d2i. So if I am taking this I as my meeting vertex, I is the vertex at which I am meeting. So d1i is the time that the first person would take to come there. D2i is the time the second person would take. Max of d1, d2 is the time of meet. So for every I, I'm calculating the time of meet and I'm taking the minimum time as my answer. So if answer is infinity, that means they cannot meet. I would print -1, otherwise answer. This part is clear. So let's look at our Dijkstra function, what I'm doing in my modified Dijkstra function. So I'm taking a source. Okay, so in my Dijkstra, we generally take a normal distance array. So here I'm taking a 2D distance array. This is vector of long n into 2. Okay, so as I told, I would store my nodes are basically from instead of 1 to n, they are 2 cross n. So my nodes are in the form of pair I comma 0 or I comma 1. So n into 2, a 2D vector I'm which is representing my nodes. Okay, so now distance of s comma check s. Now for the source, if this source contains a horse, then I would directly start from s1. Okay, and if this source doesn't contain a horse, then I would start from s0. Okay, so this check s would be 1 if the source contains a horse, otherwise it would be 0. So this, my initial source node would be s comma check s. So this is assigned the value 0. And then I'm using a set, you can use a priority queue also. This is basically the priority queue of my Dijkstra. So for the Dijkstra, the priority queue that you use. Now for the visited array, again, I'm creating a 2D vector, n plus 1 into 2, a 2D vector for the visited array. So we have n into 2 nodes. So n cross 2 matrix represents my visited array, which is actually 0. Now in my set or my priority queue, you can say this is a priority queue basically. I'm inserting 0, comma s, comma check s. Again, in my priority queue, we used to insert distance, comma the vertex. Here I'm inserting distance, vertex, and this 0 or 1 bool variable also. So it is s0 or s. S, comma check s is inserted. Now while my priority queue is not empty, this is the top of my priority queue. Since I'm using a set, I'm using st.begin. U is V1, F is V2. So this V0 stores the weight, V1 stores the vertex, V2 stores the F, basically, whether you have a horse or not. F would be either 0 or 1 based on whether you are a node where you have a horse or not. Now erasing this is basically popping. And if it is visited continue, then visited equal to 1, basic Dijkstra code. And I'm going to all the vertices adjacent to you. This is with weight, E is the vertex, W is the weight, dot first, dot second. And if now I would check if F is 1, basically we have a horse, then weight would be divided by 2. And F1 is the node where we are reaching. So if F is 1, either if we already have a horse, then we will reach V with a horse only. Or if there is a horse available at V, then also we would reach V with a horse. So F1 is F or V. So either I already have a horse or I have a horse at V. Then I would say that I am reaching V with a horse. So F1 is for V, F is for U. So I'm checking if V comma F is not visited and its distance plus U is less than this, then I'm assigning it. So basic Dijkstra code for V comma F instead of a simple V. Okay, and I'm pushing it in my gratitude. So I hope this code is clear to you. So after this, what would my final minimum distances would be? It would be minimum among I0 and I1. So whether I reach there with a horse or without a horse, it doesn't matter. Take the minimum of the two, whichever is giving me minimum, that would be my DI and return that D. So this D gives me the minimum time to reach a node from the source. So this is my Dijkstra function. I hope it is clear to you. what would be my complexity? So this is input part, basically O of H, O of M, no problem in that. This Dijkstra is taking n log n time, or and Dijkstra takes n plus m, whatever that is, m log n. I think this is the complexity of Dijkstra. Both n and m are up to 25, and this again is taking m log n. And then this loop is running n times, so this is O of n. So basically, finally, it's m log n and n. So my final time complexity is basically O of m plus m log, okay, which is well accepted for m and n to 10 to the power 5. So they are up to 2 into 10 to the power 5. So this code is well accepted. I hope this problem is clear to you all. If there is any other doubt, okay, this is a very standard problem, you can say, of graph modeling. Basically, this was a standard problem of when you have two sources and the shortest time to do two-free computation. And then that's a little modification of the Dijkstra, where you have a node, a yes and no thing added to every node. Okay. I hope this problem is clear to you. So we can move to the next problem. Okay, let's move to the problem F now. So in F, we are given the folk hero Robin Hood has been troubling Serif for years. Okay, so Serif of Nottingham builds the camps with strategy in mind. Thus, there are exactly n camps numbered from 1 to n and n minus 1 trails, each connecting two camps. Any camp can be reached from any other camp. Each camp I has initially AI group. So with these sentences, what you can understand is we are given a tree basically. So how did I got to that conclusion? Because since we have n vertices and n minus 1 trails, these are edges. So n vertices and n minus 1 edges, and any camp can be reached by any other camp. These things can only happen in a tree. So basically, if this line was not given, then you cannot confirm that it is a tree. But since it's given that any camp can be reached from any other camp, that means all are connected. And for a connected graph with n minus 1 edges is a tree. That's the definition of a tree. So we are given a tree here, and each camp I has AI gold. So every vertex has some value AI. Okay, these are the number of gold that is present in every vertex. As of now, all camps would be destroyed by Robin. Serif can strengthen a camp by subtracting exactly C gold from each of its neighboring camps. Okay, so now what it's given that this Serif, he can strengthen a camp by subtracting exactly C gold from each of the neighboring camps. So if he want to strengthen a camp I, he would subtract C gold from all the neighbors of I and not from I. Okay, then that camp would be strengthened. Okay, so only the neighbors gold would be taken. A camp can have negative gold, so you can even go to negative gold. So there is no problem. You can take any amount of gold from neighbors and they can go into negative also. After Robin Hood's attack, all camps that have been strengthened survive the attack. All other camps are destroyed. Okay. Now, after the attack, all those camps that were strengthened, they would be survived, and all the other camps, they would be destroyed. What's the maximum gold Serif can keep in his surviving camps after Robin Hood's attack if he strengthens his camp optimally? Uh, okay, camp is never. Okay, so we just need to find the what all camps would you strengthen so that after the attack, if you just consider the camps that are remaining, the camps that are not strengthened, they would be destroyed. So the sum of the golds remaining in those camps would be the amount of gold you get. So what's the, you need to maximize that thing basically. Okay, so you need to find what's the maximum goal you can achieve. So again, now let's look at an example to understand more clearly. Okay, let's look at this example. So here basically we are given a tree. So there is n nodes, n minus 1 edges, and C is given as 1. So C is the cost of any strengthening. So let's see what type of tree we are given. So this 1 and 4 are connected. So 1 is connected to 4. 1 and 5 are connected. 3 and 5 are connected. 3 and 6 are also connected. And 1 and 2 are connected. So this is the tree that we are given here. Now, the number of gold available in every is also given. So this is for 1, 2, 3, 5, 6. So 1 has 5 gold, 2 has minus 4 gold, 2 has minus 4 gold, 3 has 3 gold, 4 has 6 gold, 5 has 7, and 6 has 3. Okay, so this is the number of gold given. Now we need to find the number of camps. Okay, what all camps we would strengthen so that after the attack, the for all the remaining camps, if we sum up the remaining gold, that is missing. So let's suppose you don't strengthen any camp, all of them would be destroyed. Your final value would be 0. Okay, let's suppose you strengthen this camp. Okay, now if you are strengthening this camp, from all the neighbors, one gold would be taken. So its gold would now become from -4, it would become -3, it would become 6, it would become 5. And this camp, you can say, is now strengthened. Okay. You can say that this camp is now strengthened. Same way, if you, let's suppose, also strengthen this camp. So for strengthening this camp, from the neighbors, 1 gold would be taken. So from the neighbors, it is reduced to 5 and 2. And now this camp is strengthened for. Okay, this camp is also strengthened. Let's say you are strengthening these 2 camps only, and then the attack takes place. Then all those camps that were not strengthened, they would be destroyed. Okay, so these camps would be destroyed. You are left with these 2 camps. The number of gold left there is 5 plus 3, which is 8. So 8 would be the final gold that you get if you strengthen these 2 camps. So that way there could be many possibilities of strengthening. You need to find the by what way you can get the maximum gold. Okay, so first thing that would come to your mind, why can't we strengthen all the camps? So like, see, if there is a negative gold also. If you strengthen this camp, it would add some negative to your answer, so that would reduce your answer. So it is not the that simple greedy case where you would say, or maybe you would say that you strengthen all the positive values and not the negative value. Just strengthen all the positive values. Like if you just look at sample test cases, in most of the cases, I think you would think that this is going to work, but simply doing that is also not going to work. Let's suppose I'm giving you an example. You have something like this. This is 1, this is 2, this is 3, this is 4. Let's suppose you have 1 gold here, and you have one gold in all of them. So all of them are positive. So you would think you strengthen all of those positive values. But what would happen if you strengthen all of them? So if you strengthen this, the gold of this would reduce to 0. If you strengthen this, it would reduce to -1. If you strengthen this, it would reduce to -2. And if you strengthen this, all these gold would reduce to 0. Final number of gold you have is -2. So it was better if you don't strengthen anybody, you would get 0. 0 is still better than anything negative. So I hope you got that the initial intuition that it was looking in the question like just strengthen all the positive values, but that would not work because there is a cost of strengthening. Basically, if you're strengthening this, the neighbors are going to get reduced. Okay, but now what can we do here is, let's say in this case, what was the best case to do? Here the best case was, don't strengthen these 3 camps, just strengthen this camp. So these would be reduced to 0, and you're strengthening this camp, so you would get 1 as your final answer. So 1 is the best I think you can get in this case. Okay, or no, you could get 3 actually here. You strengthen these 3 and don't strengthen this. So if you strengthen these 3, you would have 1, 1, 1 in everywhere and a -3. But since this is not strengthened, this would not count in your answer. You would get 1 plus 1 plus 1. So you would get 3 as your answer. So like for this test case, the answer would have been 3 was the best case. Okay, so like after analyzing a few test cases, some approaches, now what can you think? What can we do here? Okay, so the problem is any greedy approach is like you are not. Uh, I was initially trying for some greedy approach, only trying to think and think. But anything if you think like if you are reducing, if you are strengthening this, it's taking the cost from neighbors. Now you don't know whether these neighbors are strengthened or not. So that would reduce my final answer or not. That you don't know. Now, if you're strengthening this, it's reducing this. So they are like interdependent. So in this case, what comes to your mind is something like a DP approach. And in trees, this most of the time, like DP on tree is a very common technique. So now how, but for DP approach also, how can you think? Basically what we have here, so like for any tree, like this is a general advice whenever you are solving a tree problem, DP on tree is a very common thing. And whenever you need to apply DP on tree, always the state of your DP in like most of the cases for DP on tree is something DPI, and then you can have one more state or maybe not have one more state. Most of the case, if you have a single state, your one of the state would be DP of I represents the subtree from I. What does subtree from I means? If this is my I, my DP of I would store the my basically my answer for this subtree. In most of the 99% cases for DP on tree, I would have a state where DPI stores the answer for this subtree. Okay, so in DP of I, let's suppose I'm storing the answer for this subtree. Now, what would my be my answer? Okay, so if I'm only considering this subtree, so DPI I stores my answer. Now you need to write the transitions. How can you write the transitions in this case? And your transitions would always be for any subtree, its relation with its child subtrees. That's what your transition is in any DP on tree problem. So let's say your I is this. If this root is your I, so like your final answer would be DP of your root. DP of your root would uh, store the answer for your whole tree. That would always be your final answer. Now, how can you write a transition for this? Let's say you are finding the answer for this subtree. You need to find a relation with its child subtrees. Now, how can you find a relation? So let's suppose I'm considering these nodes. Okay, this is one of my child subtree. This is another. This is another. Now I can now have two cases, whether this is included, whether this is strengthened or this is not strengthened. There can be two cases. On that, my answer would depend. So like if this is strengthened, okay, I'm taking one cost from this, one cost from this, one cost from this, and then whatever the answer for this would be. After this, if this is strengthened, then the number of goal remaining in this would be added to my answer. And if this is not strengthened, then a +0 to my answer, and only the values from my child subtree would be added. Okay, so now the problem is you cannot like manage these two cases like directly. If you are taking just a DP of I as your state, then you would have always two cases whether this is strengthened or not. Let's say I'm trying to write the transition DP of I, what it would be. So if I have already calculated my answer for this subtree, I'm assuming. So for this subtree, if something X is my answer, so I would add this answer. Let's say for all the subtrees, I would add my answers for all the subtrees. And then I have two options whether to select it or not. If I am selecting it, I would have to reduce one from these answers. But in what case? Like if in this subtree, the best answer was by not selecting this. And in this subtree, the best answer was by selecting this. So if you are, and in this, the best answer was by selecting this. So if you are selecting this node, then your final answer would reduce by 1 for this, by 1 for this, but it would not reduce here because this was not selected. So if you're reducing the number of coins here, that is not getting added to your final answer. So for this tree, you won't have a -1, but for those tree where you have selected, so if you are reducing one gold and that is counting in your final answer, so that would have an effect of -1 in your final answer. So what I'm doing here is, I know a single state would not work. Just take that second state in it, whether this is selected or not. So my dp of I and a Boolean variable, let's say j. So it would have dp of I0 and dp of I1. So I would have a 2D dp, and my second state would be either 0 or 1. So 0 represents that my best answer maximum value I can get for the subtree starting from node I, such that this ith node is not selected. Basically, this ith node is not stranded. So if ith node is not strengthened, then what is my answer that would be stored in this dp for the subtree? Like my answer for the subtree from I. Okay, for this subtree, what's my answer? If I'm saying that for the ith node, this is not selected. And if I'm saying that the ith node is selected, that ith node is strengthened, then what is my answer for the subtree from I? That would be stored my dp by dp I1. So now once I have these states, now writing the transitions would be easy. Now what would be my transitions? Okay, so I'm writing the transition for, let's say I have a dp. Okay, so u0. So if I have a node u and it has some children, okay, so uh, it has many children. Let's say v is one of the children. One by one, we would go to every children. Okay, what would its answer be? So this would be a whole tree in itself. So for this state, I'm telling that u is not selected. If u is not selected, that means my answer would be the maximum answer for this subtree, whether I with this as selected or not selected, it doesn't affect. Final answer selected or not selected, selected or not selected. Because since this is not selected, it is not affecting these values. So it would be just summation of dp of every v. So where v belongs to the child of u. Okay. For every child of u, either dp of v0 not selected or dp of v1. So this child can be selected or not selected. We would take the maximum among both. Okay. If it is selected or not selected, whichever is maximum, we would take. So this would be the transition for dp if this u node is not selected. And what would be the transition for if this u node is selected? Now, since this u node is selected, what I would say, if this subtree is taken independently and I have found my answer. Okay. So if I have found my answer for this, now what would be its contribution for this subtree if it is selected? So now if this was selected, we would add a -1 from its contribution. If this was not selected, we would not add a 1. So again, if this was selected, we would add a -1. If it was not selected, we would not add a minus. Now, -1 in its contribution. Since this is also selected, like if this is selected, then it would reduce 1 point from u also. So if we are selecting this, I'm telling the number of points available in, or not -1, it's -c. Okay. So the C coins are utilized there. So number of coins in, let's say the number of coins in U is represented by my array A. So AU represents the number of coins in U. So since this is selected, this would be added to the answer minus how many nodes among these are selected, because they would reduce its contribution. So basically, whenever a node is selected, the contribution is of this is reducing by C, and the contribution of his is also reducing by C because of the selection of this. So if I'm telling this is selected and I'm telling this is also selected, then when the answer for this was calculated, it was not present. So in this minus C didn't happen. But when they are connected, minus C would occur here also and here also. So basically, I would say I would have dp of V if I'm selecting it. It's also doing a minus 2C into my final answer. So either if you are selecting this, get a costing of minus 2C, or don't select this. dp of V 0. So you would take the maximum among these two for every child V. So plus this A. Okay. So for every child subtree, if you are selecting this, you are reducing your answer by minus 2C. And if you are not selecting this, whatever answer you got for this subtree, it would remain that one. So take the maximum among, if you are not selecting this, then what's your answer? If you are selecting this minus 2C, then what's your answer? Take the maximum among two. That would decide whether you would select or not. And do it for all the childs, and plus AU. AU is your contribution of this. And whichever node is selected, they would reduce. So that is done. Okay, so that you don't need to worry about. So I hope that transitions are clear now. So this would be the transitions for DP states basically. Okay, so these are the transitions for my DP state. DPU0 is for all the child subtrees, just take the maximum among V0 or V1. DPU1 is take AU plus for all child subtrees, take maximum among this or this. I hope the transitions are clear. So now writing the code would be very simple. If you know the transitions of a DP and you need to apply a deep entry, you just need to run a DFS and do these transitions basically. Let's look at the code, how we will do it. If there is any doubt, you can ask now, or we'll look at the code now. Okay, let's look at the code. So basically, I'm taking the input NNC. Again, I'm using the adjacency vector outside so that I can use in my DFS. So I'm declaring them global. So adjacency dot assign n plus 1, and then I'm just taking the input. AI stores the number of points available with the ith vertex, and then I'm taking this tree as an input UV. So edge from U to V, directed edge. And in my DP, it is a 2D DP of n cross 2, initialized by -1. So I can do the memoization in my DFS function. Now, my final answer. What would be my final answer? Is my final answer is the DP for my root. So this DFS is the function which is returning my DP. Okay, this is the DP function also. You can call it DFS or DP. So DP of 1 would be my final answer with 1 taken, or DP of 1 with 1 like not taken or taken. Okay. So my final answer basically was is DP of the root. 1 is the root, it's given. So either this or DP of 1, 1. So the maximum among this is my final answer. So DP10 or DP1. So that's what I've written, DP10 and DP11. And this third is the parent basically. So to run a DFS, you would need to maintain a parent. So for the root, we just give a parent as -1, so that it's not affecting. The root doesn't have a parent, so we give 1. So this would be my final answer. Now, how I am writing my transitions. So DPXF is my basically the states. If XF is not -1, return this is the memoization thing. Then my answer is initialized with 0. If F is 1, I would add plus AX. So for if F was 1, this AU would be added. So DPX would have plus AX. Now I would go to each child. If I is parent and continue, I would run a DFS. Now for every child, if F is 1, If f is 1, then I would take max of dp v1 minus 2c or v0. So if f is 1, dp 1 dp of I1 minus 2c or dp of I0. So if I is the child, if I have taken it, then a minus 2c. If I have not taken it, then it's as it is. And if f is 0, then I would just sum up the max amount v0 and v. So the max amount I1 and I0. So this way I'm writing the transitions, and finally I'm returning dp except as. So I hope this DFS function is clear. This DP is clear. What would be its time complexity? It's simple. We are running a DFS. These transition are O of 1. So basically this whole computation is a DP of n into 2. So it would take O of 2 into n. Each transition is O of 1. So 2 into n into 1, which is same as O of n. And so this thing is taking O of n, and these are input things only. Okay, so my overall time complexity is O of n. Okay, I hope it is clear to you. If there is any doubt in the problem, you can ask, or maybe we can end now. This was also like a standard DP on tree question only. In most of the DP on tree questions, you need to use a second state of 0 or 1 when you store something like this. Okay. So I hope it's clear. Thank you very much for watching. Bye bye.